Hello, everybody. It is Wednesday evening in Bangkok. It's Wednesday morning, I think, most other places. Welcome to another evening of Field Gemology Talks. I'm Justin K. Prem. I'm one of the hosts. You might know already if you've been here before. If you haven't joined us for one of our talks, welcome. If you've been here for weeks and weeks and weeks, welcome back. It's July 1st, and it's the 10th week in a row that we've done these talks. This is so cool, I think. We've had so many incredible conversations, and we're just going to keep on going, I guess, for a long time, because we still have a lot of guests that are, on the way. So Vincent, if you're here, let's get our conversation going on. And welcome to everybody in the audience from all over the world. Always nice to see how everybody's doing. Hi, Vincent. How you doing?
Hello, everybody.
So
Yeah, exactly as you say. This is our 10th talk. All these talk, all the previous talk are available on my YouTube channel. So if you have missed some, or if you want to see again some of them, you're welcome to go on YouTube and to find these talks. Now, as you say, yeah, it will continue for a while, but let's say the schedule is full until middle August.
okay,
So
we can
there
reassess.
are five more confirmed talk webinar to come. Then after that, maybe we'll think about, because the concept of this talk is basically that I'm inviting some of the people that I work with when I go to the field, and they are actually quite in a limited number. So after maybe August,
We've
we'll
run out of
see.
people.
We'll see. Maybe we'll change the concept. We'll see. We still have we have some time to think about it.
Yeah. And so today's, I think, maybe sort of interesting in terms of what's happening in the world, because Thailand opened today. So we're going to
Yeah.
see what happens in the next couple of weeks. I know that we're watching the rest of the world going up and down on COVID numbers, and Thailand's been very, very good. And let's cross our fingers and hope that our numbers stay very low, because I feel so safe in this Thai bubble. But
Yeah. Indeed. So far, currently here in Thailand, I was at my office today, or at the office of one of a friend today in Siloam area. So people are working, and well, everybody wear a mask, everybody wash their hands. Everything is seems to be quite well in control. Now, we are a bit. It's not exactly things as usual, because as most of the gem producing area are not exactly in the same type of situation.
yeah,
There are actually not so many stones that are coming in Thailand these days. So we don't know how long the factory will be able to do without supply, and how long the miners will be able to do without customers. Because if there is no transportation, if there is no shipment of stone from gem producing area to places like Thailand,
yeah, it's
it's
true. It's
and of course
scary.
also on the selling side, if people maybe doing online are doing quite okay, but there are not so many gem buyers coming around to buy stone and returning to their country. So
Yeah, it's true.
currently, we'll see, but maybe we'll get some good surprise, I hope, in the next few weeks.
Well, I've been trying to do my part, and I've been dropping off stones in the factory every week. So I'm trying to do my small part and keep them healthy and functional. But yeah, I know a lot of people around here are nervous, and a lot of the places are not feeling very confident right now. But we'll see. Maybe in
On the
Asia.
lab side, we have a lot of time to do some research. So
Yeah,
collaborating today, I went to collaborate on some research articles that will be published in a kind of close future. Yesterday, we released a nice one about rubies that maybe you have seen already.
yeah,
A big work that we did with Gaston Giuliani and Fadik and yeah, quite a lot of people. It's a lot of work. It was a lot of work, but okay, still ongoing.
Yeah. So we're going to be talking tonight with Cedric Simonet. So what's the story? How do you guys know each other?
Well,
Who is Cedric?
Cedric, the story with Cedric is a kind of interesting one because I first heard about Cedric from a traveling French guy. When I was a gemology teacher at AIGS around 2004, I had a student who just when he finished his gemology degree, he went to an island in Thailand, Koh Samet, and on the boat going to Koh Samet, he met a French chemist called Perry Ruffo. And this guy was traveling around the world visiting gem mining area as a hobby and bringing back some stone to sell to some friends. And also he was collaborating with Nantes University in France with Emmanuel Fritsch. And my student, who was Jean-Baptiste Noble, told me that I should speak with that guy. So he organized a lunch. And during the lunch, Perry told me that he went to Africa and he basically discovered gemstone when he visited by kind of chance. He met a French guy called Cedric Simonet, who was the manager of the Central Ruby mine. And the guy was doing a PhD on rubies. So I was a little bit curious because at this time, there was not... there was, of course, Ruby and Sapphire by Richard Hughes, but I was quite interested to learn that there was a French guy who was doing a PhD on rubies and who was managing a ruby mine in Africa in a national park. And Perry told me a lot of good things about it, and he told me that I should try to meet the guy. So then I went on internet and I searched, and I found Cedric, and I found his PhD. And I downloaded the papers that was available online. And I was very impressed with the work. So later we started to discuss by internet, and actually we met at a conference, and we became friends. And since then, most of the time when I go to Kenya, I contact Cedric, and in the past, for the past nearly 10 years, every time I go to Kenya, I travel with Cedric.
Okay. So how many times have you traveled together, do you think?
Currently, I think we travel 3 times together. We travel together in Kenya. We travel together in Mozambique, and also in Tanzania. Okay. 2009, since 2009.
Okay.
So 11 years, actually. 11 years that we are traveling regularly together.
Okay.
And we discuss when I need to find out something about geology. Usually, I either ask to Gaston Giuliani or Cedric, and sometimes, I get an answer from both. And both of them were very helpful in order for me to understand geology, because I didn't learn geology when I was studying science. I was studying physical chemistry, so basically spectroscopy and trace element analysis and things like that. But I had to learn geology traveling with geologists and reading books.
Okay, cool. Well, so shall we bring Cedric in and see what he has to say about the world and gemstones? So Cedric, whenever you're ready, come on in. Hello.
Hi, Justin. Hi, Vincent. Hi, everyone.
How are you doing?
Good, thank you.
So we have had a little bit of introduction from Vincent, but can you give us in your own words a little bit about who you are and what you do, and maybe a little bit about your PhD as well, since we're speaking about that?
You want to put the video first, Cedric? What do you want to do?
Well, maybe let's get introduced.
Just start with the video.
Okay.
Yeah.
Okay. So we'll see the video so we can get inspired and kind of understand the landscape that we're going to be talking about tonight.
Justin, you have to allow me to share the video.
Oh yeah, sorry.
it was just a name on one or two lines in most books about a gemstone from Eastern Africa. So the name Pokot was mentioned, but there was no details. This ruby deposit is quite interesting because it's an old one that was discovered in the 1950s, or even maybe before, at the time of the British. And this is one of the very few, or maybe the only known marble type ruby deposit in Kenya. But in order to go there, there is quite a lot of road, and we had some technical problem with our car. So now we are repairing the car in a kind of local condition. Fixing it. The special thing on this expedition is I'm traveling with Dr. Cedric Simonet. He's a geologist, and traveling with him I can collect the reference sample I need for the lab. So it's a very interesting combination about field study and field collection.
So that's Michael's pit.
Michael.
Yeah, each shaft is known by the name of its owner.
Yeah.
So it's just a very small hill of marbles. It's about 1 kilometer long, a couple of 100 meters wide, and it's mineralized all the way. He's using this to protect his fields and to kill dangerous animals. So he said he has already killed leopards and hyenas with it.
So actually you have the mining pit and you have a cavity dig like that and a cavity dig like that, so it looks like an eye. In the bottom there was some ruby on the rock. Quite nice. We have located with Google Earth some evidence of mining in one of the places that Cedric he went many years ago, and we found on Google Earth some photo of this mining, and now we are trying to find the place that is I think about 100 meters on the right in the bush. So we are searching a way to get as close as possible from the mining site, and then we are going walking to see what is going on there. After walking about 10 minutes in the bush, and we were able to find this pit and here this tailing where we were able to see some rubies on the floor. Pinkish, low quality corundum sample associated with mica. And so this is a former mining site from a company called Kikisa. And the samples are low quality, but they are the leftovers. So probably if there was any sample of better quality, the miner would have collected them. So this is the proof that this is indeed a former ruby mining area. And it's quite fun because we found it thanks to Google Earth. I heard about the stone long time ago, and I wanted to make sure that number one, the deposit was existing, and if possible, get some reliable sample in order to be able to characterize these stones. So one more spot on the map.
So it's kind of funny. We have this reoccurring theme that's kind of been coming up in the last few weeks a little bit, which is like technology and field gemology. And again, in the video, we see using Google Earth, which we were talking about a lot last, maybe 2 weeks ago, and you know, finding the GPS data, looking for old maps on Google Earth, and then going and finding them in real life. I like to imagine you two French guys with your smartphone, and then like, you know, 400 years ago you have Tavernier and his like young cousin, and they're like you know, traveling around in India or Persia or whatever, but with no Obviously nothing like this, just maybe a map if they're lucky.
Yeah, that deposit was fun because Cedric was, he knew the place quite well because he had been working there. I only had seen an old article in the 1950s about that. But he knew that there was another one very close. So on the way to the mine, we had a look, and I could see that because it was along the Ugandan border, there was some network. So I had some network with my iPhone, and I could check with the Google Earth. So we took a place mark, and we did some scouting on the way to Pokot. And on the way back, we decided to let's try to see if we could find this Kitisa ruby deposit. And Cedric remembered quite well where it was because I think he went there about 10 years before. But thanks to Google Earth, we were able to find the place super easily and knew exactly when we had to turn. And there was a small track, and we were able to find the deposit that was about 200 meters on the west side of the track. It was fun.
Cool. So Cedric, welcome, and let's hear a little bit about you from your words. Who are you, and what have you been doing all these years since Vincent?
All right. Well, thank you for inviting me to both of you to this webinar. I would like to start like Peter last week, saying that I started geology at 1 year old, but nobody remembers. The earliest record, I was 5 years old. I was picking fossils, ammonites, and bringing them home. I think my passion for earth sciences started with paleontology and together with that archaeology. And I started early also. When I was 8, for Christmas, I didn't want toys. I wanted East Wing geological hammer, and I got one, which I kept a long time. I even brought it to Kenya, so I kept it a very long time. So I always wanted to do geology or anything having to do with geology. I went to university in France at the University of Nantes. And I think I was quite lucky because first Nantes is a very nice city where to live, but also Nantes already had at the time a laboratory of gemology and had someone who was very passionate about geology, who is Professor Bernard Lanier, who is now retired. And so there are basically two people who took me to the world of gemstones and gemstone geology. The first one is Bernard Lanier, my mineralogy and gemology teacher. And the second one is someone called Raymond Zdei. Raymond Zdei is an old prospector who spent his life looking for different types of commodities all over Africa and also in Indonesia. Basically, what happened is that during the second year of the bachelor's degree, we had field work to do. One session in a sedimentary area, another session in an area with metamorphic and igneous rock. And that was under the supervision of Bernard Lanier. So we went to a part of France called Massif Central, which is in the center of France, where you've old rocks by European standards, Hercynian rocks. And we had to map a small piece of ground. Each student had to map a small piece of ground, which was a couple of square kilometers in surface area. When I handed over my report, I had a little bit overlapped out of the area I was supposed to map to the north. Why? Because there was a ruby deposit there, which had been previously documented in a place called Chantel. There were rubies in amphibolites, in mafic granulites, just like you find in Montepuez, in Longido. So I had gone to have a look at this, and Lanier saw that we were very interested in, me and some friends, in gemstones, geology. So he took us to visit Raymond, and Raymond taught us how to do panning with a pan, to look for minerals in rivers, to look for gold, to look for sapphires, to look for zircons, because it so happens that this part of France not only has some rubies which are not of gem quality, it also has sapphire and zircons which are of gem quality. They are associated to alkali basalts, and they used to be exploited. It's documented in the Middle Age, several deposits, and the zircons up to the 19th century. So it all happened to be the right things at the right place at the right time. So I got very interested in gemology. I got the opportunity to do the diploma of gemology at the University of Nantes. And before that, I was sent to the jewelry school of Saumur to learn a little bit the basics of gemology. And yeah, that's how it went. Then came the opportunity to go and do an internship at the John Saul mine. It so happened that John Saul had also done the diploma of gemology in Nantes. He was a good friend of Bernard Lanier. He is a good friend of Bernard Lanier. So I got an opportunity to go and do a 3 weeks internship while I was doing my master's. I went there. I was absolutely amazed with the amount of geology and amazing geology that there was in such a small area. Especially there is a place near the John Saul mine called the Yellow Mine. It's a very, very small thing with a small ultramafic body, but in the same pit, you can see probably 2 or 3 different types of ruby deposits. You can see a yellow and green tourmaline deposit. You can see a Tsavorite deposit, you can see tanzanite, and you can see even some minerals that we could not identify at the time. So I was super interested. I brought back a lot of samples. I went back to France to finish my master's degree in Clermont-Ferrand to study petrology. And while I was in Clermont-Ferrand, I used the equipment to study the samples I brought back from Kenya. I wrote a report for the management of the John Saul mine, sent it. They were very happy with it. They were interested. They invited me to come back for a summer job. And I went back there after finishing my master's, did this summer job. And it quickly turned out that there was a very, very big need to do some research on these deposits, because back in the time, there was very little information available on the geology of colored gemstone deposits. Now it has changed, but at the time there was very little. So we talked with the management of the John Saul mine, with Yasan Papaliopoulos, Johnson Mudama, who were very supportive. And we agreed that I would work at the mine as a geologist at the same time as I would do my PhD. So that's how it started, basically.
Okay, so that's a pretty adventurous story. You're kind of all over the world a little bit right off the bat. So, you know, in the last, I don't know, well, let's just say in the last 10 weeks, we've spoken to so many people, and so much of our talk has been about Africa, you know, talking about the gemstones of Africa, the geology of Africa. So maybe this is a good place to start the conversation tonight. You know, speaking about, you know, you're talking specifically about rubies, but we know from previous talks and from our experience in the trade, Africa is so rich in gemstones. Can you give us some ideas, you know, geologically speaking, why is Africa such a gemstone wealthy country or a continent?
All right. Well, to talk about geology and Africa, we need to look at a map of Africa so that we can see a little bit clearly.
I've got one.
Geologists normally work with maps and with cross sections. So you've got here a map of Africa. Before I start, 2 warnings. First, I'm going to talk only about colored gemstones. I'm not a diamond guy. I've never worked a lot with diamond, quite rarely. And I don't know what, I'm not so attracted with diamond, nowhere near the attraction I have for all sorts of colored gemstones. The other thing is that I quickly put this map together this morning. I didn't have all my databases with me. So you can see there's nothing on Madagascar because the Madagascar database is on another disk, etc. So the map is incomplete, but it will give you a good idea of what's going on. So the first thing you can see these little colorful dots. These are different gemstone deposits. It's quite intuitive, and blue is for sapphire, green for emerald, red for ruby, and so on. These deposits are not homogeneously distributed. They are not like all over the place. They are in some specific areas. And if we look more in details at the geology, we are going to understand why. Let's start with the oldest rocks, what we call the Cretons, which are very old rocks, which are several billions of years old. These are the areas which are hashed in gray in the map. This is where you would find diamond rather than color gemstones, but you can still have some old color gemstone deposits in Cretons. Between these Cretons, you have orogens, more recent orogens. Some are very old, 2 billion years. Some are more recent, like the Pan-African orogens, which are 700 to 500 million years old. Then, on top of this, you have a lot of sedimentary basins, which appear in yellow. Some of them are on top of the other rocks. And then you have the rift valleys. When you think about Africa, especially East Africa, you think about the Great Rift, which goes basically from the Red Sea down to Malawi and Mozambique, which is a failed ocean. It's a crack in the surface of the earth, which opened up, but which did not become an ocean. But a little bit lesser known to the west is also the West and Central Africa Rift, which is very important in Nigeria and in the Sahara. So these are the main geological environment. Now, if we look at gemstones, there are four types of environments in Africa where we find gemstones. The first one is the Pan-African orogens. I'm sure you have all heard about the Mozambique Belt. The Mozambique Belt is a part of the East African orogen. The southern part, which is a high-grade metamorphism, is called the Mozambique Belt. The northern part, which is lower-grade metamorphism, is called the Arabian-Nubian Shield, when you get into Ethiopia and then across into Arabia. So these Pan-African orogens are extraordinarily diverse in terms of geology. You find many different types of rocks, metamorphic rocks of different origins. Some were sediments. You have metasediments like marbles, graphite gneisses. You have metavolcanics, all sorts of rocks. And these rocks have undergone metamorphism up to often granulite facies metamorphism, which is very high pressure, very high temperature. And when you have the right conditions for the formation of gems, you get gems there. So almost all the gemstone deposits in Eastern Africa are found in Pan-African orogens. The second type of environment where you find gems is the pegmatite fields. These pegmatite fields are important not only for pegmatite minerals like topaz, tourmaline, spodumene, aquamarine. They are also important for emerald, because emerald forms as a result of a reaction between pegmatitic rocks and other types of rocks. I'll come back to that. So these pegmatite fields, the better known ones are quite recent. They are Pan-African, 500 million years old, plus minus. Like, for example, the pegmatites in Mozambique, the pegmatites in Nigeria, in Namibia, in southern Ethiopia. But you have older pegmatites, like the Kibaran pegmatites, which are 1 to 1.4 billion years old. These ones are located in Rwanda, Burundi, Eastern DRC, southern Uganda. They are producing especially minerals like coltan and cassiterite, but there is also tourmaline there, gem tourmaline. You have pegmatites from the Eburnean orogen, which is just in Togo and Benin. which are quite old. They are over 2 billion years old. And then, quite importantly, you have pegmatites also in the Archean, especially in Zimbabwe. You have pegmatites which are very old. The Archean is more than 2.5 billion years old. So these pegmatite fields, these pegmatite provinces, they don't all have the same age. And the Pan-African pegmatites are connected to the late stages of the Pan-African orogen. The third geological environment where you find gemstones is specific to emerald. And that's when you find that the pegmatites that contain beryl have intersected ultramafic rocks. Basically, what happens is that the pegmatites contain the beryllium, which is necessary to make emerald, and the ultramafic rocks contain chromium, which is necessary to give the green color to emerald. So when these rocks intersect, and there are different processes, and it's not always the same way, you have good chances to find emerald. The interesting thing is that in some cases, the pegmatites can be much younger than the rocks, the ultramafic rocks they intersect. For example, if you look at Zambia, the ultramafic rocks belong to the Muva Formation, which is 1.7 billion years old, but the pegmatites and the emerald mineralization are much more recent. They are from the end of the Pan-African orogen at 450 million years old. If you look at Zimbabwe, both the pegmatites and the ultramafics are Archean age, so 2.5, 2.6 billion years old. If you look at Ethiopia, both the ultramafics and the pegmatites are from the Pan-African, so very recent, 600 to 450 million years old. The last type of environment where you're going to find gemstones in Africa is the intracontinental rift. The East African Rift System, EARS, and the West and Central African Rift System, WCARS, very similar. You find sapphires and rubies associated to volcanism, which have been brought to the surface by the basaltic volcanism associated to the rift. You also find peridots. When the basalts come up, they often bring pieces of peridotites from the mantle of the earth, and you can have gem peridots. And also, not really from the basaltic activity, but rather from the geological formations which are created as a result of the basaltic activity, of the volcanic activity, you can also have opal deposits. So these are the four main geological environments where you would find gems in Africa. It's not the only ones. With geology, you can categorize things, you can classify things. It makes it easier to handle the knowledge, but you must be sure that you might find some things that will not fit into any classifications, that you will find things in an unexpected place. This is quite normal. So to finish about the geology of Africa and gemstones, we need to look at Africa in the context of an old continent, which was called the Gondwana. 540, 550 million years ago, all this orogenic activity had put together continental masses into a continent called Gondwana. And stuck to the western edge of Africa, you had Brazil. I'm sure you know that this gulf along the western edge of Africa was the location that eastern Brazil was occupying a long time ago, before the opening of the Atlantic. And then on the eastern side of Africa, you had overland masses like India, Sri Lanka. Madagascar was next to the coast of Kenya and Tanzania, and even Antarctica. So when you look at the world map, some deposits may look far away from each other. But actually, a long time ago, they were very close to each other. The Paraiba deposits, for example, Paraiba tourmaline deposits in Nigeria, were geographically very close to those from Brazil before the opening of the Atlantic Ocean. And also the Tsavorite deposits from Eastern Africa were very close to those from Madagascar and to those from Antarctica, because you even find Tsavorite in Antarctica. Right. I hope that covers the question.
Yeah, I think that was a great explanation. I mean, we can pretty much see that it's quite complicated and there's a lot of different factors happening all at the same time and sometimes in the same place, right?
Yes.
But you can see also there are few areas where you have a high concentration of probabilities to find some gem quality material, especially Eastern Africa and the area with Cameroon and Nigeria, plus Namibia and that link that are going around the Creton, at least for Colostone, as you say.
Yeah. Yes. Yeah, it may, these dots on the map may look like they are very close to each other, but they actually aren't. If you look at the Mozambique Belt covers almost the whole of Kenya, a large part of Tanzania, the whole northern part of Mozambique. Not all rocks have gemstones and have potential for gemstones. If you want to look for gemstone deposits, you have to go much more into the details of what's happening at the scale of a small area, like 1,000 square kilometer, 100 square kilometer, and you have to narrow down.
Cedric, just before speaking about, presenting Africa for the geology, you were speaking about your studies, but then you stopped basically at the end of your studies when you were still doing your PhD. Can you tell us a little bit what you are doing now on what happened, between the end of your studies to this period? Because my understanding is for the past nearly 20 years, it's not just that you studied, you did your PhD at the Johnson mine, but you have nearly 20 years experience of working in East African deposits, especially for gemstone, for prospecting.
Okay, let me clarify a bit also.
Okay.
Yeah, because when you start, then you continue, right? So anyway, I was lucky enough to have the opportunity to work for 5 years at the Johnson mine, and that was really a fantastic adventure. At the time, and even now, there are very few opportunities for geologists to work in gemstone mines. As you know, a lot of gemstone mining is done by artisan miners. They certainly don't have the resources to employ geologists from anywhere. And formal organized gemstone mines, there are not that many. There are a few, there are more than before, but there are not that many. So if you want to start a geological career in gemstone mines, you're going to have some difficulties. There are not that many opportunities. So after the Johnson mine, I worked in different types of mines. I worked in gold operations, gold exploration operations. I ran a gold processing plant. I worked in a fluorspar mine in France. That was quite an adventure. We were doing both underground mining and surface mining. I actually ended up being, I believe, the last underground mine geologist to work in metropolitan France, since we were the last underground mine to close in France back in 2006. I worked in an alumina refinery in southern France. And then I got an opportunity to go back to Kenya back in 2007 to do gold exploration, to do base metal exploration also in Burundi. But that gave me a chance to start to work on my own projects for gemstones with a company called Svensson and Simonet, which was basically me and my best friend, Cedric Simonet. And we did some exploration for gems in southern Kenya. We tried to reopen the Manyara emerald deposit in Tanzania. That didn't work very well. Yeah, we had a lot of fun. during the whole of my career, I tried to stay close to gemstones because this is what I like. This is my passion.
Mhm.
I absolutely love it, especially sapphire. And in the past few years, I got more and more opportunities to go back to the gemstone side of geology, and I took every single opportunity. Right now, gemstones represent about 50% of my activity, and I hope this is going to increase a little bit, even a little bit more over the next few years. And yeah, I hope that answers your question.
No, perfectly. Perfectly, because you have some young geologists who are, you know, on following us, and this is the type of questions they're asking me regularly. And I think that your answer was probably very useful for them, at least to get an idea about which area they are going.
You know, they shouldn't be afraid if they want to work in gemstones. They shouldn't be afraid of working in other commodities. Why? Because you gain a lot of experience, and you're not going to get this experience on gemstone mines. There are too few of them for them to have already standardized way of working. They are still learning, all of them. And by working in other industries like gold exploration, like mining, operating an underground mine, operating an open pit, you gain some experience which is going to be super useful in the next gemstone project you are going to have the opportunity to work on. A lot of the techniques I'm applying when I'm looking at gemstone exploration, gemstone development, gemstone mining, I learned these techniques from non-gemstone mines. Industrial minerals, base metals, precious metals. And without this experience, I wouldn't have the same way to look at gemstone projects as I have now. So to the young geologists, don't be afraid to do other type of projects. Keep the gemstones in mind, keep learning about gemstones as you work on some other things, so that when you get the opportunity, you are as well prepared as possible.
Yeah, as I say very often, you know, gemology can be a very interesting passion or a hobby. And, you know, when you don't find a position or a way to make it a living, you can keep it as a passion and then return it, you know, in a professional way, in a little bit later.
Absolutely, absolutely.
Yeah.
In your
that is the way to
experience,
go about it.
yeah. In your experience so
Justin?
far, have you found that you're able to actually transmit some of the knowledge that you, like, you know, what you were just saying, picking up some knowledge from other types of mining? Have you actually been able to share that with some of the mining groups that you've worked with, aside from your own personal research and stuff? Have you actually showed them some techniques and stuff like that?
Yes, absolutely. This is something which is very important to me. And in Kenya, I own a mineral exploration services company called Akili Mineral Services. This company works for a very diverse type of clients. Some of the clients are professional mining companies. They just need you to do the technical work. They get the data. They do what they want with the data. But some of our clients are local companies, and these local companies want to get into mining, but they don't know anything. So you have to guide them from the beginning, and that's what we do. We train our geologists to international standards. We train our technicians to international standards, and then we train our clients. And we have clients that at the beginning we were doing everything for them, and after a couple of years, they were able to do most of the things themselves. They were able to run their own surveys themselves, to do their own conclusions, their own reports, and run their own company. So with gemstones, it's the same. I try to share as much as possible of my knowledge, and I try to adapt the language I use to the audience. Not all the people who need knowledge are geologists. Many are artisan miners, small-scale miners, with various degree of education, various ways of seeing things, of understanding things, and you have to adapt the way you share your knowledge with the way people can understand it. I do that just systematically. Be it a corporate client, I will try to help them to build up their systems. If it's an artisan miner, I meet in the bush, just the same thing. In Kenya, there are several of my clients who are on a very steep learning curve. They are coming from artisan mining, getting into formalized small-scale mining, and we share even very advanced things with them, like how to do underground topographic surveying, how to do geological modeling, how to do a mine plan, how to calculate the parameters of your ventilation systems. Just, standard industry level mining stuff.
Okay.
I guess that in order to be able to do that, you need, especially when you work in a place like East Africa, you need to be able to learn quite a lot of language. The language skills are probably quite important.
It is quite important. Yes, it takes some time, but right now I can communicate fluently in French, English, and Portuguese and Swahili. So that covers quite a large part of Africa. I'm learning Amharic, which is probably the most difficult language I've ever tried to learn. I think it's just as difficult as French, although it has got nothing to do with French at all. I can now relate to the suffering of people who are learning French. And yeah, after Amharic, I think the next one will be Arabic.
Well, maybe Malagasy, if you
that's
if you
another
happen to work a
possibility.
bit on the other side of the Mozambique Channel, because there is quite a lot of potential there. And yeah, language, if you want to communicate with the people, especially the small-scale miners, you have to learn the language.
It's absolutely necessary. Wherever I go, I mean, these are the main languages that I speak or learn, but wherever I go, if I stay for a week, I'm going to pick up the basics, like how to greet someone, how to talk about stones. And then if I stay longer, I'm going to start learning the language slowly. It is so interesting. I think linguistics is something which is absolutely amazing. When you learn the languages and you start seeing the relationships between the languages, and you start to think, how did that happen? Maybe hundreds of years ago or thousands of years ago. It's as fascinating as trying to decipher the geological history of an outcrop.
It's true. So during your, your adventures and everything, when you're speaking about language, when you're talking to different people about gemstones in different languages, have you come across any sort of funny expressions or phrases? Like what's the most unusual thing that you've come across? Anything particular as far as gemstones go?
Most unusual, yeah. Sometimes the way artisans can name a gemstone, especially if they don't know what it is, can be just very intuitive. It makes them think about something, and they will call it this way. So graphite in Swahili is called mka, which means coal, literally, because it's black. So that's quite logical. Pyrite, like these big shiny euhedral crystals of pyrite that you find in Merelani, is called shaba. Shaba literally means copper. Pyrite is not copper, but it looks like copper. Okay, it's bright and shiny. They know it's not gold, so they call it shaba. Then, once in southern Kenya, there was some people mining what they call commercial garnet. That's very dark red-brown garnet in an amphibolite. And cutting across the amphibolite, you had some small pegmatites with feldspars, oligoclase feldspar. And this oligoclase feldspar was a little bit translucent, and it was a little bit cream colored. So they called this cake because it made them think about it looks like cake. So that's probably the weirdest name I've seen for a gemstone.
Cake. Okay, that's pretty good. Well, before we get too far on, we got a question from one of our audience members. So I want to bring the map back up real quick because it has to do with the map. So this is from Martin Viala. He said he's not very familiar with the geology of West Africa, but he would have expected to see gemstone deposits in Mauritania or Western Sahara associated with the collision of Laurentia and the breakup of Pangaea. What do you think about that?
I've not done any work on that part of the continent. Raymond's Day, who I talked about earlier, was in Mauritania. I don't remember him mentioning any gemstones there. He was there for iron ore, actually, and gold. But there are gemstones in West Africa. For example, in Mali, you have the what they call Mali garnet, which is a solid solution of andradite and grossularite, which can be green or yellow. The geological context of these garnets is among the exceptions. It doesn't fall in the 4 categories that I've mentioned. Again, you can find gemstones in many different types of environment. You can find that just locally there are the right conditions. You can find gemstones in hydrothermal systems, which are very common, for example, amethyst, even beryl. And again, not everything is on this map. First, because there are some things that have not been discovered. There are sapphires in the middle of the Sahara Desert. Volcanic sapphires. They are not on this map, but they are there. Mm. They've been described by French geologists in the 1930s. So what can I tell Martin? Just go and have a look. That is the only way. Huh?
Maybe if we speak to you in 5 more years, you'll have even more stuff on the map.
There will be. If you look 20 years back, the maps that I had in my PhD thesis, there was not as many gemstone occurrences as there are now.
Yeah.
Well, that was already a useful map because at this time there was not a lot of information available on internet, and probably your PhD thesis was helping quite a lot of people.
I'm glad.
Yeah.
Okay, we had another question that just came in. Are precious metals associated with some of the gemstones found in Africa? And what are the most common minerals associated with ruby and sapphires in Africa?
Okay, this is a bit of a wide question, so I'm not going to cover everything, but I'm just going to give a couple of examples which are interesting. You find gemstones associated with other minerals, other commercial minerals in many instances. For example, Tsavorite and Tanzanite occur in graphite gneisses. These graphite gneisses also produce graphite. And in some cases, even in Mozambique, they are vanadium resources. They can produce commercially vanadium. Pegmatite minerals typically contain, you can have gemstones, but you also find minerals which are important for technologies, especially in this age of all electric, like lithium. Lithium is mined in great part from pegmatites. And some gemstones are actually lithium-bearing minerals. And the pegmatites also contain things like colombo-tantalite, which is used for electronics, like cassiterite, which is used to extract tin. When it gets to precious metals, in secondary deposits, it's quite common to find gold associated to ruby or sapphire, but they don't come from the same source rocks. Huh? They just happen to be located in an area where you have both minerals. But there is one place in Kenya once where I saw an amphibolite which had ruby. So ruby in mafic granulite, cabochon quality ruby, not very good color, a little bit pink. And in the same amphibolite, you had shear zones with gold. And this is the closest association I have ever seen in my career between precious metals and precious stones in that particular occurrence. That was quite exciting.
Interesting.
Then you have also all the basically radioactive minerals like uranium and things like that that are quite commonly associated with, especially with sapphires. and some pegmatite.
Well, with sapphires, it depends. Yeah, you have I don't know if this is the one you're thinking about, but you have the one in Andrandombe in Madagascar, where this system of skarns, which produces sapphire, is also the same one that was prospected for uranium by the French back in the 1960s. I just saw a comment passing about some noise. Is there some noise when I'm talking?
I don't hear any noise. I'm not sure. I thought maybe it was me because I didn't hear anything.
Okay, all right.
Maybe it's I don't know. Maybe Jean-Claude's computer is making noise. We don't know. Anyway,
okay, no problem.
So from your experience so far, obviously you have a lot of experience as we're learning. What does it take to be a gemstone geologist in Africa? I mean, you've spoken on this a little bit, but tell us a little bit more about, what do you have to go through to get the knowledge and to be able to find the experience and all that stuff?
All right. When I came to Africa, the first time when I started to do my PhD, there was very little geological information available on gems. So it was a challenge. I really had to look at everything, and it was good. I was fresh from a good university where we had been taught how to observe, how to describe, and so on. Because I had really to start from scratch. There was very little material I could count on. If I were to come to Africa as a fresh geologist from the university today, the situation would be very, very different. I was doing a review like I do regularly on the geology of basaltic sapphire deposits recently. And now you've got dozens of papers, and you've got dozens of papers on marble deposits, ruby marble deposits, and mafic granulite deposits, and then you've got papers like the one that was published by Giuliani, Groth, Vincent, and so on yesterday, actually. So there is a lot to read, but in order to be able to assimilate the information which is in these papers, you have to read them. So you've got to do a lot of reading. That's probably not only for Africa, that's for everywhere. But you really need to do a lot of research, a lot of reading to compare what you see with what other people have seen, have described, and so on. And then you will find that reading these papers is a little bit sometimes frustrating because the papers are for academic research. They are not directly translatable into economic geology. And you, as a field geologist, you are the one who is going to have to extract the information from the papers to be able to use it in the field. These deposits formed like this, what does it mean in terms of exploration? This particular rock has got these characteristics. How can I use this for prospecting, geophysical prospecting, geochemical prospecting, and so on? And then, even worse than this, many papers leave you with more questions than answers. So you have to use your own brain to try to figure things out. You have to learn, you have to read, you have to observe. I don't know why, when I was a kid, we used to be told la curiosité est un vilain défaut. We used to be told that curiosity is something you shouldn't have, is bad. You shouldn't be curious. I tell my kids exactly the contrary. They should be as curious as possible. Curiosity is a virtue, is a blessing. And especially if you work in the field of natural sciences, especially geology, you must be curious. You must look at every outcrop. I guess, again, this is not only for Africa, it's for everywhere. But you must look at every outcrop, you must describe it, you must understand it. And it's not only about geology, it's also about nature, zoology, botany, meteorology, anything, because all this is connected. Geology, you have different sub-sciences of geology, but the most interesting thing to do when you study geology is to learn the connections between sedimentology, metamorphic petrology, economic geology, and so on. And you must be curious also about people, because wherever you will go, there are people who live there, who have different culture, different way of seeing things. So curiosity, if you're not curious, forget about geology. The other thing, you must not be lazy as a geologist. And again, it's not only for Africa. I see young geologists who go to the field with a notebook and they scribble some things on the notebook. And when it comes to the evening, they are not able to read anymore what they wrote the same day. They don't even remember. Maybe they took a photo, but the photo is not well taken and it's not showing anything anyway. I have my notebooks. I have all my notebooks since I started as a student from the early 1990s. All are legible. I can read back anything I've read, understand it, and know what I was talking about. And more importantly, I can see the drawings. The most important things for a geologist is to be able to draw. You don't photograph an outcrop. Photographing an outcrop is good maybe for Instagram or whatever. It speaks to people. But an outcrop, you have to draw it. You have to sit down, put your notebook on your knees with a pen, sit, draw slowly, and that's the way you are going to understand what is happening in front of your eyes. So you have to be curious and you have to be not lazy, the contrary of lazy. Another thing which is very important, I will use the words of a famous field gemologist, you should expect the unexpected. And this is very true. This is very true because this is how things are found. This is how artisans find stones, being open to whatever new things will come. I've showed you this map of geology. This is based on general geological characteristics of Africa, but you could find a gemstone deposit in a different environment, which has not yet been described. We classify gemstone deposits into different categories, for example, for emerald, for ruby and sapphire. But in reality, every single gemstone deposit is different. You don't find two deposits which have exactly the same characteristics. And that's why often you find, for example, inclusion suites in gemstones from the same category of deposit, but the inclusion suites are different because actually the deposits are not the same. They have some differences. Another thing which is very important, we've talked about culture and languages, but you have to connect with the local people. And the best way is to appreciate, share their culture, share their language, learn their language. This is the only way you can communicate. This is the only way you can share what you know. This is the only way you can also gain the knowledge from other people. The last thing I would say about what it takes to be a geologist in Africa, and I think I had put a picture there that you could use as an example in the presentation. Yeah, this is a beautiful picture of me when I was young and slim and all this. What I want to say is that you must be hands-on. You can't sit at the edge of the pit under an umbrella and look at people working. You have to go and work with them, everything. When I was manager at the Johnson Mine, I was able to discuss any job that the employees were doing because I had done all of these jobs. I knew how to operate all the machines. I knew also how to work without a machine using just a pick and shovel underground with the guys the whole day, day shift, night shift. This is the only way you're going to gain the experience to be able to work with people. And also this is going to change a lot the way people will respect you and the way people will communicate with you. So you have to be as hands-on as possible. I think, yeah, that summarizes the issue.
I say I completely agree with you. I will say you have to have very good observation skills, which is working with curiosity.
Oh yeah, absolutely.
Observation skills and listen to the story of the people around you, especially the people who live in the area. And because behind many stories, there is often something that is interesting, and this is a way you can get an idea about and change mind about something. So yeah, no, but I agree with what you say.
So we got.
I'll give you another example. There would be many, but let me give you another example. At the Johnstone mine, inside the ultramafic body, which is a rock to which the ruby deposits are associated, we used to see some pockets of green material, chlorite, green micaceous material, chlorite, and instead there were some bright red dots. Everybody assumed that these were rubies. And okay, let's check, let's do a thin section. We look at the thin section and the material is isotropic because it's not ruby, it's spinel. And then we look a little bit closer and we see, okay, what is this next to spinel? And we see that these little grains who were just like pale purple on the hand sample, they are actually corundum. So these rocks contain corundum, but the red thing we thought was ruby was not corundum, it was spinel. Then the assumption was that maybe this can lead us to some commercial quality ruby or spinel. These spinels were very small, like 1 millimeter. And we build up observations on these things as we mine the ultramafic body. And it turns out that the spinels never pass a size of 2 millimeter rounded. So you can't do anything with this. And yeah, if you don't look at things, you're going to assume things that are wrong. You're going to ultimately, in a commercial environment, you're going to waste time and money.
We got a few more questions from the audience if you want to do some specifics. Jerome Petit asks, is there a way to estimate the quantity of gemstones left that are still in the ground to be discovered?
Not really. First, to do this sort of statistics, people do this on other commodities like gold and some other metals. But to do these sort of statistics, you require enormous amounts of data, which don't exist for gemstone deposits. What I can tell you for sure is that there are some other gemstone deposits which have not been discovered yet. Thinking about countries I know very well, like Mozambique, like Tanzania, like Kenya, there will be more discoveries in the year to come and for a long time, because I was keeping this for later, but it's partly because of the way things are discovered. Many gemstone deposits are discovered by local people accidentally. For example, when they do bush clearing in order to open up new agricultural ground. That exposes the soils to a little bit of erosion. There is more activity, so people are going to start seeing things. And the population growth has an impact on this, because the more the population grows, the more new areas are going to be open and possibly new gemstone deposits are going to be found. Okay. So I'm very confident that there are many gemstone deposits that have not been found yet in Africa and elsewhere in the world. And I'm very confident that we are not anywhere near the end of the gemstone production potential of Africa.
Yeah, you're right. We can see that also in a place that is already populated and known. For example, in Sri Lanka, most of the gemstone discovery, and there are nearly every year, are discovered usually when people build roads. And when you see, the map of Sri Lanka, which is tiny, but this is the same type of rocks that, Madagascar and East Africa. And when you see the size of a country like Tanzania, and you see that basically there is no road, and when you look at the geological map, you see that there is laterite, and under we don't know what it is. So I guess that when people will move there, dig a little bit, they will find a little bit what is under this level of laterite, and there will be new discoveries, sure.
Absolutely, absolutely.
Sorry, I was just reading one of the questions. Somebody had asked, can you comment on the possibility of colored stones in the Bukoban Belt?
The Bukoban Belt in Kenya is very, very, very low-grade metamorphism. So to get gemstones in the Bukoban, you would need to have things like hydrothermal systems, maybe associated to cracks, where you could have some things like silica, quartz, amethyst, maybe the same sort of stuff you find in Mali, although some of the lavas are host lavas of the same composition. It would not be the first place where I would look for gemstones. It's too low-grade metamorphism for me.
Okay, and Todi Viola asks, can you explain a little bit the occurrence of jasper and gold in manganese areas? Do you know anything about this?
The occurrence of jasper and
gold in manganese areas.
Manganese areas. All right. I'm not sure what he is referring to. Manganese deposits, gold deposits, they are not so much associated. So yeah, not sure I can help on this one.
Okay, maybe he'll come back with a more specific thought. Okay, and we have another question that pretty much, I think, leads us pretty well into the next question that we wanted to talk about. Odulio Mora is asking, can you talk about mines that had only a large production and then only sporadic, as well as gems in alluvium, but then find nothing interesting in the matrix rock? So kind of going into this conversation about alluvial deposits and primary and secondary deposits.
All right. Okay, so let me talk first about the size, because this one is a quick one. You got gemstone deposits of every possible size. I saw an emerald deposit, not a deposit, an emerald occurrence in Galicia in Spain, which was the size of an outcrop, a few meters wide, and it was just there. There was nothing else. Whereas you have areas like Zambia, where you have consistently the same geological environment with emerald deposits, many of them. So you have gemstone deposits of every possible size. There are things that the artisans find which are going to turn out to be a world-scale deposit, like Montepuez. You have other things which are just going to produce a few stones, and the guy will buy some flour to continue for the next week, and that's it. The question of secondary deposit and primary deposit is quite important. Secondary deposits are very attractive economically, especially when they are large enough to be mechanized. And that can be on a small scale, on a medium scale, or on a large scale. Why are they attractive? Because often they are soft. The rock is soft. You don't have to blast it or to drill it. You just have to dig it. It's what we call free digging in mining language. Often they are shallow. The amount of overburden which there is relatively low, so it's easy to mine and cheap to mine. They can be high grade if the concentration phenomenon have worked well enough, and if there were enough stones in the source rocks. And they tend also to be graded, meaning that in a primary deposit, typically you're going to have a very low percentage of clean stones. But in a secondary deposit, all the stones that contain fractures, inclusions, they tend to be destroyed. So the stones, the percentage of high quality stones that you find in a secondary deposit is usually much higher than in a primary deposit. One thing with secondary deposits you have to remember is that secondary deposits work well, form mostly for minerals which are hard enough to resist to weathering and erosion. So typically, this is going to be diamond, obviously, ruby, sapphire, chrysoberyl, garnets, to some extent tourmaline, but minerals like emerald, you don't find them so much in secondary deposit because they don't travel well. They get destroyed very fast in dynamic environments. So that's why you will find world-scale secondary deposits of ruby or sapphire, but you're not going to find world-scale secondary deposits of emerald. You will find primary deposits of emerald. So this is important. When you look for secondary deposit, you must think, okay, how well and how far can the minerals resist to a dynamic environment, can resist to transport, can resist to abrasion. Another important concept as far as secondary deposits are concerned is a concept of source rock. You often find, okay, let's say I had this case in a secondary deposit in somewhere in Africa just last year. I was with some young geologists who were learning about gemstones, and we see a secondary deposit of sapphire, and there away on a hill we see a rock which is a potential source rock for sapphire. So I ask the geologist, the young geologist, these rocks that we see in the alluvial deposit, where do they come from? And they point at the hill. And that is very wrong. Because when you look at a stone from an alluvial system, you can't see its source rock. Its source rock has been weathered and eroded away hundreds of thousands, millions of years, sometimes tens of millions of years ago. The source rock of that sapphire we were looking at, by now, if you want its position, it was somewhere up in the sky. And it has completely disappeared. It has been completely eroded and weathered away. So this is something that is very important when you try to understand the connection between primary deposits and secondary deposits. Sometimes you will find that the source rock has partly disappeared and you can see its extension on one side. Sometimes you might find that the source rock has completely disappeared. It's very possible. At the John Saul mine, the production initially of rubies was from the soil, very small, very, very small alluvial deposit. The primary deposit that was below went down to, I think, 4 or 5 meters inside the ultramafic body. It was very shallow. And then after that, there was nothing. So the fact that you have a secondary deposit does not mean that you will have a big primary deposit associated. It also doesn't mean that you will have any deposit at all. Finding the source rocks is one way to locate secondary deposits. Obviously, if you find source rocks, you can assume that in that area there might be secondary deposits, and you're going to want to look for them more in details. But as a consequence of what I said, the less you see the source rocks, the better it is. Because the less you see the source rock, the more it has been weathered, the more stones you will have into the secondary system. So the big challenge is to find the secondary system where the source rock has completely disappeared, because that will be the richest secondary system. And in my opinion, until maybe excavations prove it different, the Mugloto deposit in Montepuez is probably mostly eroded away. And that's probably also why it is so rich and so large. When we talk about primary and secondary deposit, the best way to look at things is on a cross section. So if you can go back to your screen sharing, I think we've got a slide on this, Justin. Right, this is just a summary of the main types of secondary deposits that you have. There is a red line in the middle, a red vertical line, and to the left of it is what people classically know. This is a sketch that you will find in every textbook of geology. You have a primary deposit, it gets weathered. Right on top of it, you have an alluvial deposit, which is made of minerals which have not moved, which are still on top of the original deposit. Then, because of the effect of gravity, you have a colluvial deposit on the slope, which is usually mixed with rocks and soil coming from other areas which have no gems. So this sort of colluvial deposits tend to have a lower grade than the alluvial deposit. And then you get into the rivers and you have alluvial deposits. And as we all know, the rivers tend to move over time, tend to dig their way down, and they leave on the side what we call paleoterraces, which are also alluvial deposits, which are just old riverbeds which have been preserved on the slopes. And then these cycles can be repeated many times over time. Alluvial deposits can be reworked by other rivers and redeposited and reconcentrated. And if you want to see this sort of systems with alluvial deposits where they are the most developed, you have to go to Ilakak in Madagascar, and you are going to see alluvial systems until you get tired of them. From the Permian, the Triassic, the Jurassic, the Cretaceous, until the Cenozoic, until recent systems and current systems. Now, if you look at the right-hand side of the chart, on the right side of the red line, you have another type of colluvial deposits, which is not described so often in the literature, but which is very common. And it doesn't work only for gemstones, it works also for other minerals, for example, rare earth elements. I will come back to this one. So what happens is that you have a source rock, which can be very low grade. For example, a lava or alkali basalt pyroclastics that contains some sapphire and some zircon, but you would never mine this because first, the rock is very hard, and second, the grade is very low. However, because the minerals which are contained, which you want, are so hard, when these rocks get weathered away, if the topography is right, then the minerals are going to accumulate in an area, and out of maybe 50 meters thick of basalt or 100 meters thick of basalt, you are going to concentrate all the stones which were contained into 10 centimeters or 20 centimeters of soil or of colluvial gravel. And this is a very powerful concentration mechanism, which works very well with basaltic sapphire deposits, which works very well, in my opinion, with situations like Mugloto in Montepuez, which I have seen working very well with tourmaline deposits associated to pegmatites. And I was talking about rare earth elements. We have a deposit in Kenya called Mrima Hill, which is made of carbonatite. And it's the same thing. When you weather a carbonatite, a lot of the limestone disappears. And as a result, the minerals which are inside, which don't disappear, get more and more concentrated. So I'm just going to give a few figures on colluvial deposits from low-grade source rocks, assuming this is the case with the Montepuez ruby deposits. These are figures which are from Gemfield's competent person report. So these are public documents and public figures. If you look at the manganese primary deposits, the grade of the deposit is 100 plus carat per ton, which is quite high, but below 5% of this is of ruby and premium ruby quality. Most of the rest is of lower quality. If you look at the manganese secondary deposit, which is not very evolved because it is still on the primary deposit, it's right on top of it. So you can imagine it has not had a lot of time to evolve for the low-grade stones to disappear and so on. The grade of the manganese secondary deposit is 60 carat per ton, so it's already lower than the primary deposit. And the percentage of ruby and premium quality is 7.5%, so it's already higher than the primary deposit. And then if you compare this with Mugloto, it may be a far stretch because you don't know if the grade of the primary source was the same, or there can be many things which are different. But the comparison still works. The grade of the Mugloto secondary deposit is 2.57 carats per ton, to be compared to 100 carats per ton for Manganese primary and 60 carats per ton for Manganese secondary. But the percentage of ruby and premium quality is over almost 70%. So you can see an evolution from the primary deposit to an immature secondary deposit, and then to a very, very mature secondary deposit. And when you look at this, you understand that when you're looking for secondary deposits, there are many parameters that you have to take into consideration, which are not necessarily in the textbooks. And the only way you can understand what's happening is to try to look back in space and in time. You have to think what was happening 100,000 years ago, 1 million years ago, 10 million years ago. Where were the rocks? Geology is in 3D, 4D, including time. You don't just look at a map and it's good. You have really to look at things in 3 dimensions plus the time dimension.
That's a really interesting.
Over to you.
Yeah, that's a really interesting way to think about it, because we don't typically think about, or in terms of at least the way that I know of gemology, we're not typically thinking about time so much, but I guess when you really want to understand how things came to be, that the time dimension becomes pretty important to try and figure out what you're looking at.
One of the, for example, with what Cedric just said, one of the very interesting thing to look at when you look at when you are in an area and you are looking for you are studying a secondary deposit is the orientation of the rock. If you have some primary rock, when you see that everything is all the structure are more or less vertical, you may think that possibly there might be something that is going under. Now, when you see that it's not really vertical, but it's something like 20 or 30 degree, so maybe, as Cedric was showing in one of the diagrams, if you have a secondary deposit here, maybe the rock that were basically the brother or the sister of the rocks that were over, or maybe 5 or 10 kilometers away in that direction. So looking at the structure, looking at the direction in geological map is, all the time interesting and trying to understand exactly what happened. That's the first thing usually I do when I arrive on a secondary deposit. I look at, okay, there is a geological map around. I want to see what are the things, or I just look at the rock. But usually it's better if a geologist, provide me some sketch, and I can learn a little bit from what they did before.
It's a very important point, what you've just said about the angle of the strata, and it's very important, especially for artisan and small-scale miners, because you find, let's say this is a surface, we are looking at the cross-section, and you have rocks like a Tsavorite reef dipping at an angle into the ground. Yeah. You do your discovery here, okay? You're gonna want to continue digging into the vein down, that's what they do. And then as you do this, you're going to produce some waste. Where do you put the waste? The most natural way to put the waste is to put it on this side, because that's the side where you come from. But this side, because the deposit was actually like this before to be eroded to its present level, means that any alluvial deposits of Tsavorite, which are usually not very rich, but which can have very big stones and which are very easy to mine, is going to be here. So this is definitely not the side where you want to put your waste. You want to put the waste on the other side. It's a very important concept.
Yeah, good point. But if you don't,
and not very straightforward for most people.
Yeah. I mean, I guess if you don't really understand the 3D idea of the direction of that deposit, then you wouldn't even consider this, because you wouldn't think about what might have been there in the past.
Yeah.
Well, most of people are just doing basically what will be the most easy to do. So you put the waste basically out of the mine, and if it's going down, it's going down. This is why with Cedric, I had visiting, especially at Tsavorite mine, we had this interesting discussion about, how you should start a mine, if you should start the mine on the top of the hill, if you should start the mine at the bottom of the hill. And the question is, when you dig somewhere, it's all the time complicated to take the waste out of the mine, because if you are digging down, you have to carry the waste out. And when you blast, all the waste and all the things are basically going to a pileup on the mine face. And it will be very complicated to remove sometimes this big boulder from the place where you want to see. So mining underground on mining a primary deposit is actually very technical. If you make few mistakes, then it might become more and more difficult over time.
And costly, yeah.
Okay, so we got some questions that have popped up. Cedric, what's your view on Tanzanite in terms of how much is left to be mined? I guess this is a question many people have asked before as well. But what do you think from your experience? Is there a lot of potential to expand that base?
Well, I think so. I think there is a lot of potential because, right, when Tanzanite was originally marketed, it was marketed as a gemstone of a generation because the deposit was unique and it will end one day. Yes, it's true. It's true, but at the same time, if you go to Merelani, you find that, yes, some of the pits are going several hundred meters deep, but number one, they can still go deeper. And as the depth increases, there are technologies to get deeper. It's not yet that deep. And the other thing is that you find some shallow shafts which are still producing. Not everything has been taken out of the upper levels. It's not finished. So I think there is still a lot of production that can come out of Merelani. With time, logically, the cost of mining is going to increase. So that should translate into an increase in the price of Tanzanite being produced. This is normal. But when you compare with gold deposits in South Africa, which started just at the surface and which are now being exploited, I think, to 2 kilometers below the surface, if I'm not mistaken, there is still a lot of ground people can go. It's more of a technical question, technical mining engineering questions than geology. When you look at a deposit like Merelani, it stretches over several kilometers of length. So you can easily expect that you're going to still find stones kilometers below the surface. It's not just a rebound like this, which has been cut at the surface. It doesn't work like this. So you will find more stones a kilometer, 2 kilometers. If you look at the Tsavorite Belt in Kenya, which extends over 100 kilometers from Mwatate to the Tanzania border and then into Tanzania, into Gereve Hills, this host formation of the Tsavorite stretches over 120 kilometers. You can expect it will go for tens of kilometers underground. We will never see the end of it because we will never be able to mine to a depth that we will see the end of it.
Okay. Another question from Martin Viala. So he's saying some deposits in Africa are highly weathered with most primary minerals replaced by alteration products. What is your approach to characterize and study these deposits compared to fresh ones when most of the primary evidence is gone?
You have geochemistry. For example, if you do some exploration for emerald in Zambia, if you look at the first 10 meters, you will find that talc magnetic schist, which is the ultramafic rock you're looking for, and a biotite or hornblende gneiss can weather both into some yellow greenish stuff that you won't be able to tell what it is. But if you take an assay on it, which you can do easily with an XRF, you will see which one has got chromium and magnesium. that will tell you. So there are technologies you can use. You can also do XRD, X-ray diffraction, on the alteration minerals to characterize them. And they will give you a hint on what were the primary minerals before weathering. And then if you're studying a deposit where you have enough means, you can do drilling and you will get into the fresh rock and see what's happening with the fresh rock.
Okay. Someone anonymously asks, can geochemistry of ruby and sapphire help to determine the source rock?
To determine the source of rocks, so what would that be? Would that be the geological type, or would that be the geographical source, the location?
Good question.
All right. Well, in any case, the answer is yes. And Vincent is probably more qualified than me to talk about this, but geochemistry is part of the criteria which are used to do origin determination. And origin determination is done basically mostly through geological and mineralogical characteristics, which have to do with the geological environment and the geological origin of the gems. So the answer is yes in any case.
Okay. Yeah, correct. When geologists, most of the time, will study they like to study the gemstone in their matrix, in the rock where they form, but for us in lab, most of the time, we don't even have the surface of the crystal to play with. We just have the inclusion and the trace element chemistry. And based on the inclusion on the trace element chemistry, we can get an idea about what was around. Most of the time, you have what we call protogenetic and syngenetic inclusion. So you have some minerals that form at the same time as the ruby or the sapphire. And when you see, for example, in a ruby, you have calcite crystals. So that sounds like a ruby or a sapphire that was found associated probably with marble or something like that. So when you find amphibole crystal, yeah, that sounds more like amphibole related. So there are some patterns that enable us to put rubies and sapphire in this and that classification. And actually, when we do origin determination, it's much more easy to do like geologic type origin than to do country of origin, because sometimes you have deposits that are geology doesn't know borders, so we can easily classify the type of deposit where the stone is from, but you may have the same type of geology in different countries, and sometimes some geologic deposits are going over the border, like especially in East Africa, where you have the border between, let's say, North Mozambique and Tanzania, and then Tanzania and Kenya. So if you want to find, for example, we are speaking about Tsavorite, the Tsavorite that you have in the Umba area in northern Tanzania, and the ones that are on the other side of the border in South Kenya, that will be probably kind of difficult to separate.
Okay.
Yep.
And speaking about ruby still, this is from Gord Ogle. He's asking, does ruby quality improve with the depth in primary deposits?
That is the $1 million question that every miner is asking, and I understand why Gord is using this. It can, in some circumstances, but you can have very different situations. Let's say just one simple example. You can have variations of the grade of a deposit, and I think I was going to talk about this in the next question, but it's okay. So imagine you have a layer which contains gems, and you have a lens in the middle of this layer, which has better quality gems. So if you start from the middle, by luck, you're going to start with good quality, and as you go out towards the outside, you're going to go into lower quality. If you start from the side and you go this way, you're going to go from lower quality into better quality. Okay? Then you have to imagine that this layer can be tilted or can even be vertical. So you can have a situation where you're going to go down, you're going to get better quality, then it will become worse again. this is just a general statement, just to say that it's hard to tell. I have seen examples of ruby deposits, metasomatic ruby deposits, where the geology suggests that the fluids were coming from a lower level, going up. If that is the case, and there is a reaction, a metasomatic reaction, you expect that the fluids will react first, and maybe more, with the lower part of the vein with which they are reacting. So you expect that at least the mineralization will be different, and because there has been more fluids, maybe more reaction, maybe the mineralization will be better. And I've seen some deposits which suggest that in some cases like this, yes, the mineralization will improve with depth. But it's mostly in deposits where you have this phenomenon of metasomatism. With metamorphic deposits, it's a lot more tricky. The variations, I've seen variations. I remember a sapphire deposit in southern Kenya where we found a colluvial deposit associated to a primary deposit, and most of the stones were gray with stars, nice gray star sapphire, but full of inclusions and cracks. So we were not able to do anything. And then all of a sudden, we found a pocket where there was gem quality, blue, purple, pink, and color change sapphire. And then it was gone, it was finished. And that pocket yielded just 10 stones that could be cut, and that was finished. So you have to look at the deposit to understand it, to understand its geology. In some cases, yes, it's possible that quality improves with depth. In most cases, it's going to be rather a random thing.
Okay. Good answer.
Yeah.
Okay. So I guess we've already kind of started going into what our next topic was going to be, which is about how gems form. So shall we just continue on and
Yep.
go a little deeper into that? You know, just getting more specifically into how we get all these different types of gems and, you know, how they come up.
Sure. Let's get to the next slide
Okay.
to illustrate what we are going to talk about.
Yeah.
Right. These are 4 photos of Corundum. Let me not call all this ruby, from Montepuez. And you can see very well, photo A, this is brown Corundum, completely opaque, stony. You wouldn't dare to call this a gem or a ruby. D is material which is between opaque and translucent, but which has a good red color. It will make nice cabochon, probably. B is material which is already a bit glassy. The color is not, it's a bit pinkish, but it's already a bit glassy, so you can expect that you could find some gemstones. This is manganese. And then C is a mix of stones which were from Montepuez, which are gem qualities that you can facet with different colors, not all the same quality. All this comes from the same type of geological formation in the Montepuez area, all of the samples. So it's very important when you deal with the geology of gemstones to understand the impact of quality. If you look at gold versus gemstones, you have a rock which may contain 10 grams of gold per ton, so a grade of 10 grams per ton. And you know that you've done the metallurgy, you know you will be able to extract 85% of this. So you know each ton of rock is going to give you 8.5 times the price of gold in dollars per gram. This is the revenue you're going to get. With gemstones, the grade is an important figure, but the grade does not tell you how much you are going to get. The grade is a quantity of that gemstone per ton or per cubic meter of rock. Carats per ton, carat per cubic meter, gram per ton, gram per cubic meter. Because every single gram or carat of gemstone you will get from this deposit will be different. It will not have the same quality. Some will be top quality. You all know what are the main factors that enter into the value of a gemstone. the color, the transparency, the inclusions, the size also. So when you look at a gemstone deposit, the quality distribution of these stones inside the grade is super important. And among gemstone deposits, like here in Montepuez, in the Montepuez district, you have a huge variety of qualities. When you look for a gemstone deposit, the first thing you are going to look for is a mineral species. You look for ruby, you're going to look for corundum first. You need to have the right condition for corundum to crystallize. These are not common conditions. Corundum is made of alumina. In normal rocks that contain silica, alumina is bound with silica and makes silicates, any sort of silicates like feldspar, like kyanite, whatever, mica. So for a rock to start crystallizing corundum, you need to have enough alumina and you need to have very little silica so that alumina can express itself in the rock. The second thing you are going to need is a color. So in the case of corundum, you're going to need to have the right chromophore elements that will give the color. In the case of ruby, you're going to need to have chromium into the system. The third thing is a transparency. And this is probably the most interesting thing. First, to make a transparent gem, you need to have the right conditions for this to happen. Usually, this is something which has not been studied a lot. Okay, so I'm more giving you my opinions and my observations and rules of thumb. And this is an avenue for geologists to do some research on, academic geologists. But transparency, typically you need some space. Stones that grow in pockets, like tourmaline pockets where there is space, they tend to produce large, clean crystals. Aquamarine, quartz, tourmaline, these sort of things. Stones that grow inside metamorphic rocks, which have been subjected to high pressure and temperature, they will, in some occasions, produce a little bit of gem quality material, but mostly they are not going to produce gem quality material. They are going to produce cabochon quality material. But the other important thing also is that before the gemstone form, you have a rock. It's called a protolith. You may have a metasomatic reaction, which is going to affect this rock, which is going to change its chemical composition, and then the gemstones are going to crystallize. Or you may just have metamorphic reactions. So you have a rock with a certain composition, and then the changes of mineral assemblages due to the changes of pressure and temperature are going to allow new minerals to crystallize, including, for example, gemstones. So the protolith is very important. One observations we made on the metasomatic ruby deposits in southern Kenya and in northern Tanzania is that you can have many different rocks which are desilicated. If the rock which gets desilicated is a pegmatite, a very nice clean pegmatite, white, homogeneous grain size, made of mostly quartz and feldspar, few accessory minerals. This, when it gets metasomatized, is going to produce large ruby crystals. And in these crystals, you will find some of them are gem enough to be polished as cabochons or even cut. But when you find that a gneiss, like a biotite gneiss, a fine grain biotite gneiss or a graphite gneiss, is at the contact of the ultramorphic body, you find that the gneiss might have been desilicated and might have grown some corundum, but this corundum is going to be full of inclusions of graphite or of biotite, as the case may be, of sulfides, and it will be absolutely useless. So in terms of quality, you have to look not only at the rock itself in its present state, but you have to think also in terms of protolith. What was the rock before metasomatism, before metamorphism? I don't know, this is a bit technical. I hope it's clear enough. The other important thing, when we try to think about the criteria of formation of transparent gems, it's not only about how they formed, where the conditions right for the gems to form. Because once the gems are formed, a lot of things are going to happen. Rubies from mafic granulites form in granulite facies metamorphism. This is between 20 and 30 kilometers below the surface. By the time they get to the surface, so that we can see them and so that we can mine them, a lot of things have happened. Even if the stones were gem when they formed down there at the bottom of the Earth's crust, a lot of things can happen in their history that is going to make them lose this gem quality. You can have fractures. Some of these fractures will heal through different stages of metamorphism. So you will have fluid inclusions in planes coming from the healing of the stones. A lot of things are going to happen which are going to make the stones lose their gem quality. So this is something you have to think of. And again, this is something which has not been studied, or there are very few papers on this. There are some, but there are very few. And then the other things that I think one has to keep in mind is that not all of the deposits have the same age. The gem deposits in the Mozambique Belt in Eastern Africa, most of them are about plus minus 600 million years old. Some are a little bit younger. The gem deposits in Southeast Asia are more towards 30 million years old. It's not the same age, meaning that the deposits in East Africa had 600 million years old, 600 million years for the gem quality to be destroyed by geological phenomena, whereas the ones in Asia had only 30 million years. So I hope this, I'm very conscious that my answer to this question does not bring you a lot of very helpful answers to the questions you might have. It brings more questions than answers. But I think these questions need to be answered. And I'm hoping that some of the young geologists who are listening to this are going to take up the challenge and do more research on this aspect of geology of gemstone deposits.
No, I think it's definitely an interesting way. You know, even if it's not a complete answer, it gives us a point to think about for thinking about formation of gems and over time. Okay, so we've spoken quite a bit about ruby. Shall we switch over a little bit and talk about Tsavorite? Because I know you have a bit to say about Tsavorite, and we have a question in the question queue about Tsavorite as well. So let's talk about Tsavorite and tanzanite a bit. Why are these stones so rare? And you know, what does that tell us about the geological environment that they're formed in?
Okay, thank you. Tsavorite is a stone that I absolutely love. I can't say the same about tanzanite, but this is my personal opinion. Not important. Tanzanite and Tsavorite are actually very similar. I used to say it's almost the same thing. They have the same chemistry. They are made basically of silica, alumina, and calcium. They have the same chromophore elements, even if they don't give the same color in the structure of Tsavorite and the structure of tanzanite. They are colored basically by vanadium. Some cases, some contributions from chromium. But they have a different crystal structure because they formed in slightly different geological conditions. So they are not the same minerals. They are two separate minerals. Because of these similarities, you would expect that they formed under a relatively similar geological context. And to some extent, it is true. Both Tsavorite and tanzanite deposits formed in graphite gneisses of the Mozambique Belt, which underwent amphibolite to granulite facies metamorphism. It is also true that you find Tsavorite as a kind of accessory mineral in Tanzanite deposits, and you find Tanzanite sometimes as an accessory mineral in Tsavorite deposits, although the quality of this Tanzanite is not the same as the one from Merelani. The conditions of formation of the Tanzanite are not the same. So in the details, there are lots of differences between Tsavorite and Tanzanite. But what I find very interesting about these gemstones is that when you think of it, they raise some very interesting geological questions. There was a lot of research on Tsavorite done by the team of Gaston Giuliani since 2010, and then some other people also more recently. So the geology of Tsavorite is better understood than it was 20 years ago, 30 years ago, 50 years ago when Tsavorite was discovered. As I said before, when you read scientific paper, you have to try to interpret and understand them and see how can I use this information to prospect or to mine to find gems. One question that Tsavorite miners will always ask you when they are mining and when you visit them is how can I find the next pocket? Tsavorite occurs in pockets, which seem to be more or less randomly distributed in the ground. So the question is, how do you get to the next pocket as fast as possible so that you can sustain your operations? And the Tsavorite miners often try to guess where the next pocket is going to be. And in the process, they are trying to follow something that they see. That can be lineations, that can be different things, that can be quartz veins, that can be instinct, that can be the dip of the formations, whatever. But when you look at the results of the research that was done by the team of Gaston, and I would like you to go to the next slide, please, Justine. You find that the pockets of Tsavorite originally in the original sediments before metamorphism were evaporites like gypsum. Evaporites, as their name says, formed by the evaporation of water, which contains some salts, and these salts crystallize as gypsum. The host rock of the Tsavorite pockets is graphite gneiss. The graphite gneiss was a sort of mud in the bottom of a basin, which formed in a reducing environment. That's why it has graphite. The organic matter did not get oxidized, it got preserved and later metamorphosed into graphite. And that's why you find also a lot of pyrite in graphite gneisses and associated to Tsavorite and Tanzanite. So when you look at the type of paleo environment that Gaston suggests, the evaporite deposits which became later Tsavorite formed, well, it looks like the photo that is on the right-hand side of your screen. You see this gray flat mud in a sepra in an environment where you've got a lot of evaporation, and you have these white patches which are evaporites. And then you have to imagine, you have to make the mental effort of imagining that you get to the picture which is on the left. These sediments were covered by other sediments and then were metamorphosed at a depth of over 10 kilometers below the surface of the ground. So when you look for the next Tsavorite, you are actually looking for the next patch of evaporite, which was in a basin which was formed before the start of the Mozambican orogeny, so probably 700, 800 million years ago. This is what you are looking for. It is a bit like you are walking on this flat ground with a blindfold on your eyes, and you are told to find the next patch of evaporite. So it brings the complexity of prospecting Tsavorite to a level which is is just amazing. And one of the challenges when you try to help the artisans is to make them understand that in these conditions, there are very few situations where you will actually be able to predict where the next Tsavorite pocket is. You will be able to say you are in the right layer, what they call the reef, but you will not know where is the next pocket. Meaning that in these conditions, the only thing you can do is to try to move as fast as possible so that statistically you will hit the next pocket as soon as possible and your productivity will be higher. What that means is that if you're mining Tsavorite, instead of going left and right and trying to guess, you're much better off going straight and going as fast as you can, improving your productivity. And you will get, by the end of the month, by the end of the year, you will get more stones than by the way you're doing it now. Mm. Another very interesting thing about Tsavorite and Tanzanite and some other gemstones from Kenya and Tanzania, like magnesian tourmalines, dravrites, cornerupine, is that when we say, okay, why is Tanzanite blue, why is Tsavorite green, why is green tourmaline, chrome tourmaline green? It's because of the chromophore elements, obviously, the chromium, the vanadium, the titanium, all these things. But there is one thing we often forget. These stones have these nice colors also because they don't contain any iron. I was always amazed when I started to do a microprobe analysis on tourmalines from Kenya, on Sapphires from Kenya, on cornerupine. There is no iron at all in these stones. And even if you look at the Jansol mine rubies, which are from the same area, the same geological formations, they are some of the lowest iron containing rubies that you will find. If you look at the paper from Giuliani, Groth, Pardieu, which we are talking about, you will see this, and I'm sure that Vincent will confirm. The Jansol mine rubies are extremely poor in iron. So this is something which is very interesting because you have to figure out why. It seems to be important. If there was just a little bit of iron in Tsavorite, it would look brown. I've seen that once. It can happen. It would look very ugly. Nobody would want it. My theory is that these rocks are in a reducing environment. They don't contain a lot of iron for a start, but there is iron in the rocks. And in a reducing environment, maybe the iron is trapped from an early stage in sulfides, which would make it unavailable for other minerals who grow in this rock, like Tsavorite, like Tanzanite, etc. So that's my theory. I think that the reducing environment of the graphite-bearing formations of the Mozambique Belt has also an impact on the color quality of the gems you find in by trapping the iron into other minerals. But again, that's an avenue for research. Nobody has really checked this. This is just my own gut feeling, so don't rely on what I'm saying. Start the research. And then one last question about Tsavorite, which is disturbing me a lot, and which I would like to find the answer, is why is there no Tsavorite so far in Mozambique? Because graphite gneisses in Mozambique, we don't lack them. There are plenty of them. They are some of the largest deposits of graphite in the world. And vanadium is there because, as I said before, some of these deposits are also vanadium resources. So definitely the general geological environment is there, and the degree of metamorphism and all this. So what's missing? Is there Tsavorite, but we've not found it yet? Or is it that there is something that is missing? Maybe the immersion phases when evaporite form did not happen on the side of Mozambique, so no evaporites, no Tsavorite? We don't know. We have to find out. There are still a lot of exciting things to discover in geology of gems in Africa.
Well, there is a Tsavorite not very far from the border of Mozambique. Mm-hmm. There is a Tsavorite in Rwanda, in southern Tanzania.
Yep.
Actually, not that far from northern Mozambique. So maybe, as you say, one of these days we'll find. I think there is still a lot of things that that will be found in southern Tanzania and in northern Mozambique. I think this area are very unexplored, and we might expect maybe the expected that some interesting thing will happen.
Yeah.
And so I think we sort of answered the question already, but I'll ask it just because it's there. Someone had asked, what's the production potential for Tsavorite in Kenya? And do we expect to see Tsavorite discoveries in other countries, such as, bordering Tanzania? Is it possible?
I didn't hear well the second part of the question.
Do you think, is it possible to see new Tsavorite discoveries in other countries such as Tanzania and the countries that border it?
Okay. First, there are relatively well-known deposits of Tsavorite, both in Kenya, in Tanzania, and also in Madagascar, which are classics, I would say. But there are Tsavorite deposits in other places also. If you look at Kenya, most of the Tsavorite production is from the Gem Belt, but you find also Tsavorite in Samburu County, you find Tsavorite in Turkana County. Most likely there is a Tsavorite in West Pokot County. I mean, it's all over the place. Wherever you've got these formations, these metasediments with rough agneses, you find Tsavorite. Same thing in Tanzania. Okay. In terms of production, I think the potential for production of Tsavorite in Kenya is huge. I think the deposits are just barely touched. Most of the mines I've seen, the tunnels are going in not more than 200 meters from the surface, and it's just along a line. And you're talking of a line which is inside a plain, which extends on hundreds of meters, and these clusters of plains extend themselves on 120 kilometers. I think the biggest challenge to develop the production of Tsavorite in Kenya, and I think it's true also in Tanzania, is to get the miners to change the way they mine, to make it more efficient. I've talked about the mining strategy, going straight and fast as opposed to going left and right and left and right. But there is also the equipment. The equipment is very important, the mining method. Simple things of mining engineering like blasting methods used in the Tsavorite mines are very primitive, not very efficient, and they can be upgraded. And as these things happen, Tsavorite production will go up, productivity will go up, Tsavorite production will go up. The difficulty of the Tsavorite market, upstream market, is that it's very fragmented. You have a lot of players. You don't have one big company like you had in Merelani with the Tanzanite. So it makes it more difficult to bring the progress to all these players and to get them to adhere to it. I think the day there will be one significant, even medium-scale player in Tsavorite who can run an operation properly, the way it should, the way it was done with the Tanzanite in Tanzanite 1. When this will happen, production will go up, and the other miners will start learning also on how to do things in a different way.
Okay, totally interesting response. Thank you. Okay, one more question that's up. It's been up from when we were still talking about Corundum. Someone had asked, what method can be used to determine the age of Corundum? And this might be a question for Vincent as well.
Well,
okay, I'll answer with what I know maybe, and then Vincent can take over from this. If I'm not mistaken, you can date an emerald just based on the material, but for Corundum you can't. You can't date Corundum. What you can date is a host rock, if you have access to it, which is in most of the case not the case. In some cases, you can date nowadays Corundum, zircon inclusions, zircon or monazite inclusions inside the Corundum. And this is a way over the past few years we have been able to find out that sapphires brought to the surface by alkali basalts formed roughly at the same time as the basalts themselves, showing that there is a genetic connection between the formation of the sapphires and the formation of the basalts, even though the sapphires didn't form in the basalt. So there are ways to date corundum crystals by dating their inclusions, but for this to happen, you must have an inclusions, you must have access to it. So most stones, you won't have this. If the question is oriented towards geological research, well, yes, it's possible. If it's oriented towards origin determination, it's probably a lot more challenging. But for that, I will let Vincent gives us a little bit more information.
Yeah, well, there are ways. For example, if you have access to the mining area and you have access to the stone, and if the deposit is a primary deposit, and you can, for example, if you have mica, if you find zircon, if you find monazite, if you find associated mineral, you can get an idea. Now, regarding the inclusion, yeah, there are in inclusion in gemstone, you have basically three types of inclusion. You have protogenetic, syngenetic, and postgenetic. So, for example, if you find inside a sapphire a crystal that is well crystallized, or that was maybe rounded means that, you know, the crystal was formed before and maybe then was alterated. So there might be a protogenetic. All the crystals that were taken, for example, like zircon inclusion inside some sapphires. So you might be able to date the zircon. That will give you the information that the sapphire is younger than this age. Recently, there was some work that was done by some geologists on post-genetic inclusion, especially with rutile. So if you can date, for example, rutile and zircon in the same stone, that will give you a bracket, because rutile will form after and zircon form before. So you will know basically the age where the corundum was formed. And by the way, this is one of the ways where they were able to date the age of formation for the rubies in Greenland at about 2.7 billion years old. There was some work that was done on zircon monazite and some other work that was done on rutile. So it's possible in some cases, but of course you need to find a stone where you have the different type of inclusion you can work with. And again, with different methods, if all the methods are bringing you more or less the same age, then you can get an answer.
And so if you can determine the age of a sapphire or a ruby or a sapphire, what kind of information can we extract from that understanding? I mean, you said already a little bit, understanding how it's formed in the rock or when it's formed in the host rock, but what other things can we understand from the geology point of view from dating gemstones?
Well, we can find where the stone is from. For example, if you find that an inclusion in a stone is maybe 2.7 billion years, you might get, a zircon inclusion. If you have seen, for example, in a gemstone in this and that deposit, that zircon are about that age in this deposit, while in another one, the zircon are all about 40 or 50 million years, then this type of information might lead you to be able to say that you believe, for example, that this ruby or this sapphire was formed maybe in the context of the Mozambique Belt, around 500 or 600 million years old, or maybe, in the context of the Himalayan orogeny that, was happening between 50 to less than 5 million years, because I think the youngest known corundum deposit in the Himalaya is in Nepal, around 5 million years old, and the oldest is about maybe 45. So if you get the age of formation, at least you can separate, let's say, Burma with Sri Lanka, Madagascar, and Tanzania. which is already kind of an interesting possibility.
Okay, that's interesting.
Absolutely.
Is
And in terms of geology, it helps to understand how the deposits form. The genesis of the basaltic sapphires has been a mystery for a long time, and it's still not solved. So this is one of the criteria that help to narrow down the field of possibilities. So that in that respect, that's very useful.
okay.
But one thing I have to say, this is a very new technique, and currently this is not a kind of mainstream technique that is used in lab. It's more something where on the gemological side, research is starting, and very few labs have this capacity to be able to identify, to find the age of a specific inclusion. Currently, I think it's more a research tool, but who knows? Maybe in 5 years or in few years, this will have a regular application in the work of gemologists who are working on some stones.
So in terms of, because I know one of the ones you guys said that they're using a lot to date is zircon. When they're actually, in this research point of view, when they're actually dating zircon, is this done through a visual microscope test, or this is an advanced other kind of test?
Well,
It is very advanced.
Associated with some very high-tech, like laser ablation ICP-MS or even better, where you can basically identify not only the trace element chemistry, but also the isotopes.
Okay, so then they're actually doing like radiocarbon isotope dating. Okay,
Exactly.
But
so which is already very few labs have access to an instrument like laser ablation ICP-MS, and most of these laser ablation ICP-MS are not really able to work too well with isotopes. So you need to go to the next step in laser ablation ICP-MS.
So this is definitely kind of a new frontier of, or possibly a new frontier of gemology testing. That's cool.
Yeah.
Okay, so Cedric, let's talk about prospecting. You've obviously worked in different, as you said in the beginning, gemstones, other kinds of minerals, metals. Let's talk about, how do you go about prospecting for gems? Can you tell us a little bit about your experience and your methodology?
All right, so if you want to find gems, basically you've got two options. And I would like to go to the next and I think last slide.
Okay.
These are the two options you have. Either you follow the artisans, because they are the ones who find the gems, who are very good at it. And most colored gemstone deposits are found by artisans. And not only colored gemstone deposits, anything, gold, colombo-tantalite, copper, anything that an artisan can exploit will be prospected by artisans. The other options you've got is to look for them yourself, which is very challenging. Okay, you can remove the slide now. I've made my point on this. Thank you. So, how are the gemstone deposits found and by who? Mostly, gemstone deposits are found either by luck. I talked earlier about a situation where people are going to open up grounds with bush in order to do agriculture. Maybe someone is going to see something at the surface. Someone is going to dig a pit latrine. That's how the color change garnet deposit in Charia in Kenya was found. And there's going to be a discovery. The other possibility is systematic prospecting, and that the artisans are very good at. I have always been amazed when I walk around. It can be in the desert in Turkana, or in Mozambique along the streams where there are many streams, there is a lot of water. And you find evidence that artisan prospectors have been doing prospecting every 15 meters systematically, each branch of the streams. In Turkana, it's a desert, there is no water. They don't do panning, they do dry winnowing to look for gold. And they do that very, very systematically. The when you look at the locations they've sampled, this is the same thing the same way I would prepare a stream sediment sampling program. I would sample the same locations. They are very good at it. And the other thing is that the artisans are many. A large company which has a lot of resources and which wants to do stream sediment sampling might put 3, 4, 5 teams in the ground, each with 2 technicians or maybe 3 technicians with a geologist. So in one day, they are going to sample X locations. But the artisans, there are thousands of them. They are covering a lot more ground than anyone else can do. And that's why they are finding things. If you look for things, you will find. The key to finding gemstones is to do prospecting. If you don't do, you will not find. But gold in Africa is a lot more widespread than gemstones. So although you will find that some gemstone deposits are found by artisan prospectors, what you often find is that these prospectors were looking for gold systematically, because gold is more widespread, and then they found gemstones also by accident. In some other situations, artisans are looking directly for gems. So one of the biggest challenge for the artisans is that not all the ground is accessible easily to gem miners. If you look at the southeastern Kenya gemstone belt, there has not been any major discovery recently. The Tsavorite deposits, everyone knows where is the line where they pass. The ruby deposits, sapphire deposits, well, we still talk about Umba, the Johnsol mine, aqua mines. Nothing new has been found recently. Why? Because there is a lot of laterite cover in this area. It's dry. There are no streams. You can't do alluvial prospecting in the streams. And so how do you prospect? Some areas you will find outcrops. You will be lucky. Or the soil will be very thin and you see the minerals at the surface. Some other areas, there is 3-4 meters of soil and you can't see what's below except where you've got ant hills, where the termites have brought minerals to the surface to build their ant hills. And this is a very recognized way of prospecting. This is a way in Southern Africa people prospect for diamonds. You sample the ant hills, you look at the minerals, and you look if there are indicators of minerals for diamond. Well, in Kenya, the artisan prospectors traditionally have been looking at the sediments from the ant hills to see if there were chips of gems. But the ant hills are not everywhere. So you've got actually a very large proportion of the surface area of the southeastern Kenya gemstone belt, which is not prospected because you don't have access as an artisan to what's happening below the surface. And there are other parts of Africa where you have other challenges, different challenges. But basically, this is to say that the artisan prospectors, as efficient as they are, they don't have access to all, they will not be able to discover all deposits which are there in the ground. Now, you might ask yourself, what are the latest technological advances that we can use we can use in gemstone prospecting, and what are the challenges? But before I get there, you might ask yourself, have I ever found a large, reasonable size gemstone deposit? The answer is no. All the deposits I've worked on have been discovered by artisans. I have used geophysical methods, geochemical methods, different methods to find extensions to these deposits, to characterize these deposits, to develop these deposits. I have discovered gemstone occurrences, but not big ones. And my challenge, my life challenge now is to find one large one using only the latest technological advances and my knowledge, not going and following artisans. Not that there is anything wrong doing this, but trying to bring everything I've learned around, during my career into a major discovery. So when you think about doing gemstone prospecting, what I'm going to tell you now, you know, you have to make your own experience, your own mind into this, because there are many different ways to look at things. But the important point is that gems do not have a specific signature. If you're looking for gold, you're going to look at the compositions of the soil. You're going to look for gold traces in the soils. Okay, and these traces in the soil can be as low as ppb level when you are using the most advanced methods, things that you would not even be able to detect with any other method. So you're looking for gold, you prospect for gold. There are other criteria you use also to help you, but you look for gold itself. When you look for gems, it's a lot more complicated. For example, aquamarine. Aquamarine is made of silica, alumina, and beryllium. Beryllium is not found only in aquamarine. You can find it in the rocks. Finding a beryllium anomaly in the ground is not going to tell you that there is beryl or aquamarine or gem aquamarine or even good quality aquamarine. Ruby is made of alumina, which is a very common compound, and is colored by chromium. There is no trace element in ruby which is specific to ruby. Chromium, you will find it in every single ultramafic rock that exists on Earth, and not all of them have ruby. Not all of them are associated to ruby or to emerald, which is also colored by chromium. So you don't have any direct thing which can take you to the gemstones. As a result, you can only use indirect criteria. And to use indirect criteria, you have to study very well the characteristics of the target mineralization you're looking for. You have to really know exactly, okay, I'm looking for a ruby in mafic granulites. What is usually the chemical composition? What are the likely geophysical properties of these rocks? What is the likely geological environment where I will find them? What can help me to narrow down and to get to the areas of interest? You're looking for ruby or spinel in marble. Marbles are common in Eastern Africa. There are not rubies and spinel everywhere. What are the specifics of what you're looking for? And from there, you can use a wide variety of prospecting techniques. I saw a question from Gort passing about remote sensing. Yes, you can use remote sensing, but remote sensing, again, is not going to show you where the gems are. They are going to show you where certain type of geological formations are, how they are trending in the ground, how certain geomorphological characteristics are. And from that, you as a geologist, you're going to have to figure out where are the most potential areas. And then you'll have to go into the ground to do more research and to look for the actual gems. Lately, I found, okay, since I worked at the Johnson mine, we've always used geophysics. Geophysics was very useful to locate, for example, ultramafic bodies. In this particular situation of southern Kenya, it's not the same everywhere. And by locating ultramafic bodies, we were able to narrow down on some areas with potential for ruby. So you can use geophysics. Lately, I've used a lot geochemistry while doing ground prospecting for gems. I find it very useful because you can map easily and very quickly, cheaply, with an XRF, handheld XRF. I think it's a wonderful tool. You can map the geochemical characteristics of an area of interest, and that tells you a lot about the geology. Again, that doesn't tell you where the gems are, but once you know, let's take Zambia, for example. Your target is going to be places where pegmatites intersect talc magnetite schists, which are ultramafic rocks. So the soil geochemistry will show you where there is a chromium and the nickel. It will show you where are the talc magnetic schists. If you do a bit more advanced geochemistry, you will see the ones which are richer in chromium, which are better for mineral mineralization. And then the pegmatites are radioactive. Well, as in not scary radioactive. They are more radioactive than the background. So you can detect them using radiospectrometry. You have to combine all these tools to determine which are your areas of interest, and you have to do some test pits, then you have to do some drilling, and that's how you go about it.
What is your thinking about? You're more looking like for primary deposit or more looking for secondary deposit? Because there is pro and con with working a primary and working a secondary.
Right. If I look at a regional scale, I will look for primary deposits and secondary deposits separately. For example, if you look at a geological model like Ilakak, this is something huge. You are looking for your secondary deposit at the scale of the continent geology. You don't have to bother too much with the positions of the primary deposit. As long as you know there is a global area, and that's, for example, the whole eastern part of East Africa, you can use that as your source rock in the model. But if I look for smaller targets, when I say smaller, I don't mean necessarily small, but not a whole region as a target. Really, to pinpoint a target that will turn out to be an economically viable deposit, then as a primary deposit is going to be super important to me. Not necessarily because it is viable. As we've said before, an emerald primary deposit may be viable because you won't have a secondary deposit, but a ruby primary deposit may not be viable. But for me, it will help me to narrow down the area where I can find the secondary deposits. And then around these primary deposits, I look at where are the places where it's most likely that there is a secondary deposit. So for me, in prospecting, primary deposits in day-to-day life are super important. And that's why I really put a lot of effort in understanding the geology of primary deposits and in being able to predict which are the areas of interest.
Yeah, that sounds you know, well thought, because primary deposits are, well, if you look at emeralds that are probably the economical one, emerald, Tsavorite, Tanzanite. I don't know many secondary Tanzanite, Tsavorite deposit. The only place I have seen secondary Tanzanite was probably Tunduru, you know, but economic deposit. Now, if you look at ruby sapphire like a harder stone, of course, I will favor, you know, a secondary deposit. About when you were explaining this thing, it was reminding me when you know, at the beginning in Montepuez, when I was discussing with geologists, and it was exactly right what you were saying. You know, when you know that there are gems in the area, if you want to find the stone, it's actually quite easy. You are following the small-scale miners. If you see a concentration of small-scale miners, actually, you know that there are stones because they don't have capital, so they have to be able to make an income in order to be able to eat every day. So if there are many in a place, it means that probably they can make a profit. So that's the most easy way. It's you know, you see a crowd of people, there is something interesting in that area. Now, for primary type deposit, it's more complicated because as you say, you know, in East Africa, we can see that you may have a place that is very good, but without the right equipment, without the right technique, most of the deposit, even if they are good, will small scale people working with small scale method, traditional methods, etc., will not be able to go very deeper than maybe 10, 20, 30, or 40 meters. It will become very complicated. So actually, there are both deposits, so I think that there are some deposits that were already discovered that will be interested to be rediscovered, because probably some of them were maybe not work correctly. I have seen also a lot of small-scale miners, working on a place, and then they find something, or there is an event, they hear something else, so they leave that place and they go to another one. So there are some places that are known as a secondary deposit. Maybe they were worked like only 5%, especially in places like Ilakak. I have seen people, people were working in 2000, then they left the area for 4 or 5 years, and then another guy found a stone, then there is another rush in the same area, and then people leave after 1 year, and then 5 or 6 years later, there is a third rush in the same area.
Yeah.
So, yeah. For secondary deposit, what is all the time fascinating me, it's a little bit the same as what you were showing for Tsavorite, because the thing you were explaining for Tsavorite and the evaporite, that is also working for the rubies in a place like Mogok. Actually, for secondary deposit, it's about where are the gemstones going to be trapped? How, exactly what you were saying, what happened before, and how, the landscape, how you can explain that here you will have a concentration of gemstone and about 100 meters, away, there is nothing. So it's about where will gemstone, after the rock are destroyed, where they will be trapped. And in many places like Ilakak, you have a little bit like you were showing with your evaporite. Actually, you have a small pocket here, a small pocket here, a small pocket here. In an area, you may have 3 or 4 small spots with a gemstone, and in the middle, there is nothing. So maybe 200 meters away, a little bit on the north, especially you can have a different depth. People are working maybe a layer of gravel that is maybe 5 meters deep, but maybe there is an excellent one that is 2 meters deep, or there is another one that is 10 meters deep. So it's gemstone exploration is actually super fascinating. And when I listen to the stories of people, how they discover, this is one of my favorite subjects when I meet somebody, is I like to know how they discovered the place, because you hear a lot of great things about, you're speaking about exploration. You had these guys in Montepuez who were telling me about the bamboos, how they found the thing, how they found something that is workable. And you had one of these guys, hunter, he said, well, I'm going where there are bamboos. I say, bamboos, why bamboos? I say, yeah, because when I find bamboos, there are gravel, not very deep. So, and he was going prospecting everywhere he saw bamboos. And he found, and I guess that this is the way the place called Nakaka was discovered. When I asked how Nakaka was discovered, people say that it's in a bamboo forest, and because the guy saw that near at the place called Central, you had also bamboo.
Yeah.
He recognized the vegetation. He was looking at the type of trees you had where the gravel were not too deep, and he knows that bamboo need water. So if you have bamboo, it means that maybe you have gravel and water. So he was searching everywhere, and this is the way he found Nakaka. Yeah. And that was super interesting.
This is a good criteria. And to give another little piece of information to Gort, when you do remote sensing, you can discriminate the type of vegetation based on its spectral signature. So you can actually process a satellite image, hyperspectral satellite image, and you can tell right from the satellite where the bamboos are.
And you can also look at the size of the trees. Another guy told me the size of the trees. You look at the trees from a specific species, and trees will grow bigger where basically they have nutriment and where there is soil or maybe a good layer of gravel. But when there is no water and things like that, they will tend to be smaller. So if you have big trees, that's much better than if you have small trees. So
it works sometimes.
Yeah, well, it's not working all the time, but at least you can find some of the on the side of the ant and the termite. I totally agree with you, and I know a deposit that is outside of the diamond side that was discovered mainly with ants exploration. It's the emerald deposit in eastern Madagascar, where a local gem merchant, he had some experience with mining gemstone, and he read the story about exploration with diamond with ants, and he applied that in the jungle around Madagascar. And over the next, from the end of the 70s to the beginning of the 90s, over 15 years, he discovered about 20 emerald-rich localities, just looking systematically at all the ant hills, getting the ant hill collected and spreading everything on a table and checking with a loop in order to see if you could find any small piece of green emerald.
Yeah.
So, yeah, a lot of hard work.
That's exactly what that's exactly what the most advanced labs in South Africa will do with your samples for diamond exploration. It will cost you between $200 and $300 per sample. They will separate the minerals. They will identify those which are indicators for diamond, those which are general indicators like garnet, pyrope, those which are proximity indicators, because when you find chromium diopside, it's a very fragile mineral. So that means you're near the source, near your kimberlite. And that's something similar we do in Kenya, in Mozambique, with our soil samples, with our stream sediment samples. Yeah, absolutely. It's very, very easy to do. You can train. Well, this guy trained himself, the guy you're talking about. But you can train easily people to do this, and it requires very little equipment.
Yes.
He was a knowledgeable guy at the beginning. He had access. He was from a reasonably wealthy family. He knew how to read. He had several books, and he read a lot. And he was quite an educated guy. So I think that helps.
Mm-hmm.
So Cedric, we got a couple more questions from the audience before we wrap it up. Felix Rotich asked, is the ruby and pink sapphire found in Baringo, Kenya, similar to the gems found in the southern part of Kenya?
It is not similar in terms of geological origin at all. It's completely different. And also the characteristics of the gems are quite different. The ruby from Baringo is hosted in basaltic sapphires, and colluvial deposits derived from basaltic sapphires, whereas the rubies from southern Kenya are mostly of metasomatic origin. Some of them are also metamorphic.
Okay, cool. Thank you.
Yeah. The only one in southern Kenya that will be close to Baringo is probably Simba.
Mm-hmm. That's a very small occurrence.
Yeah.
And so this person is asking, what do you estimate to be the potential of copper, zinc, gold, silver, etc., in gem-bearing marble belt in southeast Kenya? And he's saying specifically in the Taita Taveta and Kajiado and Narok areas.
In the marble belts.
Yeah,
the marble belts, you will find base and precious metal deposits associated with marble when you have skarn deposits. That means when you have a granitic intrusion next to it, which has interacted with it chemically and in terms of temperature. This is very unlikely to happen in southern Kenya. If you look at the gemstone belt a bit more generally, you have some rock formations that have a bit of potential for base metals and precious metals. You have copper occurrences, but they are very small so far. It's not obvious that there should be anything. The Kenya government is currently running airborne geophysical surveys not for the first time, but for the first time in a long time. So that might generate some data which will show the possible presence of base or precious metal deposit in southeastern Kenya or not. We'll have to see the data to find out. It's not completely impossible, but it's also not very, very, very likely.
Okay. And I think this is a good one as our final question from the audience. Cedric, what's your favorite mineral or gem specimen that you've ever found?
That's a good question. My favorite thing is actually it's not something I found, but there is, okay, I'm going to talk a little bit nicely about Tsavorite because I love Tsavorite, and I think Tsavorite as a stone that you would give to your loved one is something very exceptional. It has, it carries something of very pure, of very genuine, you know, with no cheating. Because Tsavorite is a stone that you can't enhance. So far, there are no synthetics. It's probably possible to make synthetics, but there are none. So when you get a Tsavorite, it is as it was formed in the ground. It's not been heat treated. It's not been oiled like emerald. It's not been, you know, glass filled or whatever. And I mentioned the name of Iason Papailiopoulos, who was the managing director of the Jansol mine when I got there, and who was instrumental in making sure that I would work there and do my PhD at the same time. And he was a very curious guy. He had several patents about things he had invented. And one day he decided, he had bought a brand new furnace, and he decided to heat treat the Tsavorite to see what would happen. And he was unsure about the sort of medium he should use to put the Tsavorite in, so I think he used gypsum, and the whole thing went terribly wrong. The gypsum made some sort of acid which burned down the box in which the stone and the gypsum was, and it went through the furnace, and basically the following morning he found his Tsavorite below the table on the ground, and the Tsavorite had melted and had re-solidified as glass. And he gave me this piece of black glass, and I made a cabochon out of it. And this is the thing I like the most in the things that I have. Okay, I love Tsavorite, I love blue sapphire, Paraíba tourmaline, but this little piece of Tsavorite glass with its story, that's my favorite thing.
Okay, I think that is a good one to end with. Vincent, do we need to say anything else? I feel like we've heard so much today.
Yeah, no, I truly believe that Eastern Africa, on general, is probably the place where new discovery will happen in the next 50 years. Basically, I still have about 20 years, working with gemstone and going in the field and things like that. When, of course, this COVID stuff will be past. And I keep a very keen eye on Eastern Africa, because when I see all the discoveries that happened in the past 30 years there, I think that we are not yet in the middle of it. So I believe that all this area, Madagascar, North Mozambique, Tanzania, and Kenya are probably the place where there will be new discoveries. And there are people like Cedric who are, in the ground, boots on the ground there, who are doing some excellent work trying to understand the whole area, not working with books, with maps, but also working a lot with the people, keeping connection, and going there and actually doing some field work. So this is I think that there are a lot of elements now with all the information that is also available on internet for more people to find things. And I will, in place like Madagascar, there is not 3 or 4 months without a small rush to happen somewhere. It doesn't mean that it will turn into something big, because maybe the stone are too small, maybe the stone are too included, maybe it's not the right color. But everywhere in Eastern Africa, nearly every month or every 2 months or 3 months, there is somebody who finds something new. Very few of these discoveries are ever recorded. Sometimes it's just about 2 or 3 photographs on WhatsApp. And then for the next maybe 10 years, you will never heard about this place.
Yeah.
So I think that many things will happen, many exciting things will happen. And I wish that one of these days, Cedric will tell me, you know, Vincent, I think I found the place. I found the place, and maybe we need to do something about it. So this is what I wish, you know, and yeah, it might happen. It might happen.
Okay, well, the other final question as I put up our closing screen, Cedric, someone had asked, and I'm sure maybe more people have thought of it, how can we find your PhD thesis? Is it available online?
My PhD thesis is not available online. I should put it on ResearchGate. Okay. My PhD thesis by now is a bit obsolete. There are some interesting things in it, but there has been a lot of research for the past 20 years. So it's probably more interesting for someone to look into research papers on the geology of gemstones, which have been recently published. There will be a lot more information.
Okay.
I will put my PhD thesis, I think, on ResearchGate sometime soon. So it will be available there. Otherwise, ResearchGate is the medium that I would advise people to go to when they are looking for papers and information, because a lot of the papers are available online there. So you don't have to go and buy them from the publishers. Mm-hmm. You can contact the authors. There is a very old standing tradition between academic researchers of exchanging reprints. Reprints used to be you publish a paper in a magazine and you get reprints of your paper, which you are going to share with, going to send to your friends, other academic researchers, or people will ask you to send or will trade with theirs. And this tradition is continuing nowadays, but with e-reprints in PDF. And ResearchGate is the best place where you can get e-reprints from. So I would encourage people to go to ResearchGate and to look at a wide range of publication about what interests them, especially the most recent ones.
Okay, that's a good tip. And so if
yeah, I totally agree with that. And if you are also my publications, they are all on ResearchGate. There is no other place where they are.
Mm-hmm. Okay. And so, yeah, if people want to get a hold of you, or at least follow along with what you're doing a little bit, Instagram or LinkedIn, you're active, so people can find you this way. So yeah, thank you, Cedric, for a good chunk of your day. It's been a really, really interesting talk, and I think for me and Vincent, and our audience, just getting deeper and deeper and deeper into what's going on in East Africa, because it just seems like we have talked to so many people who are experts in various things, and I almost feel like we could make a compilation of all these East African conversations and make a super video somehow, but that's an idea for another day. But anyway, for today, thanks for your input and for your story. It's been super fun, and of course, thanks to our audience for coming back week after week after week, 10 weeks in a row now. So, and we're going to keep on going because we see we have Are Gemstone next week. I'm very excited about this.
Yeah, Armil will be quite a different type of talk, because the talk we'll have with Armil will be about the culture of the sapphire trade in Sri Lanka. So it will not be about geology or things like that, but it will be about this culture that is more than 1,000 years old in Sri Lanka. And as you know, Sri Lankan traders are all around Africa. They're also in Bangkok, and they have sapphire in blood. And it will be very interesting to listen from Armil, who was my first contact in Sri Lanka. And since 2005, every time I go to Sri Lanka, Armil is my regular contact. So we have about now 15 years of collaboration together. And I think he will have a lot of interesting things to speak about.
Yeah. I know the first time I went to Sri Lanka, Armil was incredibly helpful. Armil and his father were incredibly helpful in helping me piece together the story of Sri Lankan gem cutting. And we had such a good day together with the whole family. And I think there isn't anyone that, as far as I've met, that doesn't like Armil. He's just a magnetic character full of charisma. And I think it should be a great talk. I can't imagine it couldn't be a great talk full of laughs, because that's Armil. So
He's a man of many facets. He when he was young, he learned about cutting, then he learned about heat treatment, then he learned about he knows many facets of the sapphire trade in Sri Lanka. And I think that yeah, I do agree with you. It will be a very interesting one.
Yeah. Okay, so thanks to everybody for being here, and of course, this is going to go up on YouTube whenever it goes up. Really,
probably Sunday, Monday, Tuesday, depending how busy will be Didier, my cameraman, who is now doing his dive master, in Qatar. So if he is very busy, he will. It will take a little bit of time. I cannot really predict. We'll see.
Well, sooner or later. They're all going up as they do. But yeah, if you guys are not following us already, I assume everyone is, because we say this every week. But of course, you can find Vincent on all the social media platforms, as well as myself. And now you can find Cedric on Instagram and LinkedIn. So yes, Cedric, once again, thank you for being here. Thanks for your time.
Thank you so much. Thank you for inviting me, Vincent and Justin, and for this very nicely led talk. It was really a pleasure. And thank you for all the people who were there to listen.
Yep. Thanks a lot, Cedric. It was great. And thanks everybody to have taken some of your time to listen to Cedric. I think it was very successful. I heard about a lot of very interesting things. And I think this webinar will be very useful for people in the future who want to learn more about the geology of gemstone from East African deposit.
Yeah.
The reference.
Okay.
Thanks,
well, Vincent, we'll see you next Wednesday.
Yep.
Okay.
Ciao.
See you, everybody. And thank you again.